should already know what we mean by an object has a velocity and what we mean when we say an object has uniform motion. If not, you may want to check out this video first. In this video, we're going to look at how the velocity of an object depends upon the forces acting on it. In physics, we have three fundamental laws of motion, created by Sir Isaac Newton way back in the 17th century. Today, we are looking at the first law of motion, sometimes called the law of inertia. Newton's first law says that an object will remain at rest or in uniform motion in a straight line unless acted upon by an unbalanced force. But what does this actually mean? Firstly, it means that when an object is not moving, it will remain at rest until an unbalanced force acts on it. The statement also tells us that an object will remain in uniform motion in a straight line unless acted upon by an unbalanced force. Take a look at this ball here. As the child kicks the ball, they exert an unbalanced force on it, changing the ball's velocity and causing it to move. But as it rolls along the ground, the ball will slow down and will eventually come to a stop. Because the ball is slowing down, we can say that its velocity is changing. By Newton's first law, this means that the ball is experiencing an unbalanced force. In this case, it's the force of friction that opposes the motion and eventually stops the ball. Note that there is no forward force on the ball. She is no longer kicking the ball, so there is only backward frictional forces which slow the ball to a stop. Look at the diagram of the aeroplane shown. If the thrust of the engines is equal to the drag force, it will move forward at a constant speed. The plane will travel at constant height if its weight is balanced by the lift force from the wings. We have uniform motion. If the plane wants to move faster and increase its velocity, then the thrust force pushing the plane forward needs to increase. It becomes larger than the force of air resistance and creates an unbalanced net force. The plane now accelerates, no longer moving with uniform motion. Drag increases with velocity, so very soon the plane will have balance but larger forces again, and its velocity remains constant but higher than before. Quantitatively, we can find the net force of any object by considering the size, or the magnitude, and the direction of each force acting on an object. It can help to draw on the forces yourself. Take a look at this example here, which shows three forces acting on the object. The two vertical forces are equal and opposite, therefore cancelling each other out. However, the horizontal force has no opposition, and so it remains unbalanced. This means that the net force will act to the right and will have the magnitude of the horizontal force. When working out the net force, it's a good idea to consider the horizontal and vertical directions separately. At the end, these directions can be added up to give you a diagonal force. You can think of these forces to be a bit like points on a compass. If we add together north and east, assuming the forces are equal, we will get a result of northeast. Now you try. What direction do you think the resultant force will be here? Pause the video and have a go. The resultant force is obtained by drawing lines parallel to the forces to make a parallelogram or rectangle. Well, first of all, we need to find the resultant horizontal force, like this. Then, we need to draw the lines parallel to the forces to construct the resultant force. Did you get it right? To recap, Newton's first law of motion, the law of inertia. Objects will keep doing what they are doing when they experience no net force. They will continue to move with uniform motion or remain stationary unless an unbalanced force acts on them. This unbalanced force will cause them to change their velocity, speed, and/or direction, which depends upon the size of the direction of the net force. If you want to see how we calculate these net forces, then watch our video on Newton's second law of motion.
If you liked the video, give it a thumbs up and don't forget to subscribe. Comment below if you have any questions. Why not check out our AddyESchool app as well?